what are different concepts we want to know and what major things we should know under data warehouse. Just let me tell you brief introduction about this one. First, before going to this data warehouse and before going to this data warehouse definition and data warehousing process, we want to start with the operational systems. Hello, somebody is speaking. I'm not able to hear you. Does anyone having any problem? Please mute yourself. We are getting some resound. Okay, thank you. No, still we are getting, please. One second, please. Hello, Teja, are you there? Could you please mute them? Otherwise, give me organizer permission, I will mute them.
Hello, sir.
Yeah, could you please mute them? Otherwise, we are getting some noise. Yep, thank you. Okay, right. First, we want to discuss about what is this operational system and what kind of operational systems are there while implementing any data warehouse, and what are the major systems which are going to implement under this operational system. Means if you are running any particular business, each and every business will have some operational systems. What is this operational system? The systems which we are maintaining on any business to maintain day-to-day transactional data are nothing but operational systems. Okay. These day-to-day operational systems, whatever we have in a business, those are used to maintain daily transactional data, and those are backbone to our enterprise. Our general examples for these operational systems are our normal core banking systems and account opening systems, ATM transactional systems, online reservation systems. These are normal day-to-day systems which we are going to observe as a operational system. If we are talking about a particular business, for example, if we take a banking industry, in a banking industry, there are some operational systems there which we are going to use as upstream system while implementing projects. If you take in a banking, we have account opening front-end system is there, and card processing systems are there, and we also have ATM transactional systems is also there, and universal banking systems is there, and loan processing systems is there, means loan transactional systems is there. Like this, for every business unit, whatever we have in the business, to maintain every business unit data in warehouse, before, that one, what are the data already exists in that particular business, that is going to have for every business unit, there is some operational systems are there, right? Already every business is maintaining an operational system to maintain daily transactional data about the business. What are the basic characteristic features of this particular operational system? What are the major basic characteristic features of the operational system? Means these are going to be continuous availability is there, and predefined access paths. Here, continuous availability of operational systems in the sense, just if you take a call center of even any banking industry or telecom sector, anything also, this will be available 24/7. These systems which are available here as operational systems in any business, those will be available 24/7. Those will maintain daily transactional data. That is simply we can call as these operational systems are continuous availability. And what are the data we have in these particular operational systems? If you want to extract the data from operational systems into our data warehouse or something, we are any end user also want to access the data, there are some predefined access paths. Just common example. Today we open an account in a bank, right? I want to check my balance in online, or I want to transfer some amount from my account to other account, or I want to see what plans I have in my account. Those kind of information if you want to see in online, we have some user ID and password will be there. Okay, without there is no predefined access paths. If you want to see like normal information, is it possible to view the data? No chance. Means whatever the data we are maintaining in operational system, to view the data, to access the data, there are some predefined access paths also available. And next one is the transaction integrity will be there. When we are trying to capture one information related to one particular transaction, all the related transactions information also will be able to available. For example, I want to know information about a particular bank account. When I want to know information about a particular bank account, it shows what are the plans he have with this account, or what are the plans he has in this particular name, okay, and what kind of transactions are occurring on this one. Total information about that particular business will come into output. That is nothing but a transaction integrity. Okay, that whenever we are trying to capture the information about a particular business unit or particular information, the transaction integrity will occur while accessing the data from especially operational systems. And volume of transaction will be high. Why volume of transaction will be high in operational systems? Because these operational systems will maintain day-to-day operations about the data. Because of day-to-day operations are there, for example, today we open an account. Tomorrow morning, once we got all our documents, ATM cards and everything, we start, checking for balance inquiry and changing the passwords, changing the PIN numbers, or adding some other amount, other information, or updating the mobile numbers, checking the balances and doing some transfers. There are multiple transactions you have doing on that particular card, right? While fetching the data from this OLTP, volume of transaction is high. Why? It shows all information. But actually, while loading the data into warehouse from this operational system, we are going to summarize the data. But when we are maintaining the data in operational system of every business, we are going to have volume of transaction is very, very low. Okay, so data volume of transaction will be very, very high because it is going to capture all the data. And generally, while generating any report, data volume for query will be very low. Okay, just a second. Right. What is this data volume for query is very low in the sense while generating any report, because when comparing of warehouse reports, because warehouse report will come on daily basis, on a monthly basis, or if you, what is the way you want, or if you want complete year report you can get. But what is the volume we are going to get in this particular kind of reports? We are going to have these reports on only lowest volume of data will come. It's not going to have highest volume of data or something. Okay, data volume for query will be low. And generally, this is used by operational staff who will access the OLTP system. For example, we are making calls to our friends. We are receiving calls from our friends or parents or something to our mobile. Whenever these kind of transactions are happening, where these transactions are going to store? In call center, right? Who will use the data? Are we going to use the data, or the top level management of that particular business is going to use the data? No. Generally, the people who are executing or who are using or who are doing operations are nothing but a call center executive. Those simply we can call as a operational staff. Okay, whoever is working as operational staff, those people will be useful for operational systems data. Those people will use this data to generate any kind of reports also. And one more thing is, this is used to support day-to-day control operations. This day-to-day control operations in the sense that is used to run the business, not to take a decision making. Because Whatever the data we have in operational system, that data is not summarized data. That is transactional data only. Because of that is a transactional data, that data will be useful for only support day-to-day operations about the business. That is not used to support any kind of business changes, or that is not used to support any kind of decision making process. It's simply used to run the business, means to do day-to-day control. That's the only we can perform with using of operational systems data. And generally, large number of people will access this operational systems data while implementing any particular project, with any particular warehouse also. Even you can see large number of IT employees will access the OLTP data for processing of the data. At the same time, large number of end users or customers also will access the data to generate different reports, right? These are the basic characteristic features of operational systems. Means, before implementing any data warehouse, for every project there are multiple operational systems in there. Now let me show you one project architecture. In that project architecture, we can identify some operational systems, how they have, and what are the names of those operational systems, how they are going to combine to load the data into warehouse from our source systems. Just I'm showing you one project architecture, how it is built to implement a warehouse. One second. If you have any questions, please ping me. We'll unmute. We can discuss. Just I'm opening one project architecture. See here. This is one of the project architecture. In this project architecture, we can identify that there are multiple source systems there. These source systems are nothing but operational systems. Whatever we are capturing, these are going to have a fully operational data which is happening in actual business. Here, if you observe these systems, whatever we have, these are going to send the data to our data warehouse, right? These source systems, if you observe here, what are the source systems is available in this particular project, and this is a banking domain project, just I told you. We have first source system, that is nothing but a AO. AO means account open front end. This account open front end in this particular project will be useful for opening account data, whatever we are maintaining, and prospect customers, purge customers, transactional customers. These all the data is going to maintain in AOSP. That is one system which is reside on Linux operating system. Second system also there on the same Linux machine, that is called workflow. That is going to maintain all the workflow transactions about the business. And next one is the second system is that is CAMS processing system is there. That is nothing but we are going to simply have some kind of consumer account processing systems is also there. These consumer account processing systems, whatever we have, these consumer account processing systems are reside in some IBM AIX operating system. Means in Linux it's another flavor. That data also we are going to extract on daily basis. These consumer accounts data as per the health plans about that particular customer who are taking in a bank. Like this, we have multiple systems here, and third system is nothing but a AP, application processing engine. That's application processing system, APS. This application processing system, whatever we have, this is reside on system Z. System Z in the sense here, it's a mainframe. That mainframe also we receive the data, this application processing system. That data also we are going to process through ETL server. And next is cards data. This cards data system is going to maintain all the kinds of cards data, whatever is operating by our bank, right? Like this, we have multiple systems there. These individual operational systems, whatever we have, or source systems, whatever we have, is going to maintain, each and every system is going to maintain application-oriented data. Here, what is this application-oriented data mean? AO is an application which is going to maintain only account of open data. And here, OH cards is on system. This is going to completely maintain the credit cards data. And this is APS is one system, that is processing system. This is completely maintain information about call centers, right? Like this, we have multiple systems in there. These multiple systems are having multiple different application oriented data. This data, whatever we have in these applications, need to move into one consolidated database that simply we can call as a data warehouse. Okay. To implement a data warehouse, we are going to use these operational systems or source systems as a source to fetch the data and to load the data. Right. This is about the operational systems and their characteristics. Any questions here? Okay, this piece is okay, different one. Actually, just to show you what kind of source systems we have in a project, I just open this project architecture. We'll discuss okay this kind of project architectures also. Just okay. Let me go back to our actual side of basics. Right. We just now discussed about okay what is this operational system and what is the basic characteristics of operational system. Just let me discuss first definition of data warehouse. Then we'll go for what is the basic difference between operational systems and data warehouse systems. Right. Every day, every business is maintaining their data and daily transactional systems. Whatever the daily transactional systems we have in any business, okay, those data will not directly useful for business analysis and reporting as well as for taking of any decision because the data is completely transactional data. But now we want to create a one database which is should have summarized, multidimensional, integrated, subject oriented like this kind of data. Right? If you want to maintain one big database, that is what we want to maintain as a data warehouse, then what are the basic principles of this data warehouse? What are the basic definition of this data warehouse first? For this data warehouse, there are two fathers give the definition. First one is Ralph Kimball definition. Second one is W.H. Inman definition. Right. What is the definition according to Ralph Kimball? Okay, this is not the definition of Ralph Kimball. Actually, Ralph Kimball, okay, we don't have his info. This is the guy who is, okay, we can see here is nothing but W.H. Inman. Right. First, let me discuss the definition of this Ralph Kimball, then we can go for W.H. Inman also. According to Ralph Kimball, a data warehouse is a specially designed RDBMS. The data which we are storing in the database should support for questioning the business and analyzing the business rather than transaction processing. Okay, that is simple definition for data warehouse. What he is explaining in his definition is, while we go for the definition of this particular Ralph Kimball, he explained his definition. A data warehouse is a specially designed RDBMS. Here that is nothing but a relational database management system. What is this relational database management system? What type of data we have in this one means all the data which is storing in tabular format will have a relationship between one table to other table. That's what data warehouse we are simply going to call as a relational database management system. And data which we are storing in that RDBMS tables, that data whatever we are storing which is useful for analyzing the business and questioning the business also rather than transaction processing. Here rather than transaction processing in the sense normal okay inserting the data or updating the data. Apart from normal inserting and updating, the data whatever we are storing in operational system that is from onto warehouse which is okay RDBMS, that should be useful for analyzing the business and questioning the business rather than daily transactional data. Means as per Ralph Kimball, okay, he gave a definition, but that is not very that much clear. He is not explained clearly about what type of data we want to maintain and okay those things. But next second definition or second generation definition is given by W.H. Inman. What he gave in his definition. According to W.H. Inman, A data warehouse is a specially designed RDBMS. The data whatever we are storing in that RDBMS should support following characteristic features. What are those following characteristic features means? First one is subject oriented, second one is integrated, third one is time variant, and fourth one is non-volatile, right? If any database which we are creating has these four features, then I'm going to call the database is nothing but a data warehouse. Okay, right. He is also explaining about the data warehouse definition. A data warehouse is a specially designed RDBMS. Means he also told that a data warehouse database is a relational database management system. Means the inside the tables whatever we have, okay, those tables are having some relations between one table to other table with primary to foreign key relationship also, right? Now, what is the meaning of this object oriented? What is the meaning of this integrated? What is the meaning of this time variant? And what is the meaning of the non-volatile? We will discuss one by one. Characteristic features are one by one. We can also discuss here about these basic things about this data warehouse definition according to WH. First, let me discuss what is the subject oriented. When we are getting the data into operational systems or front-end systems, the data will not be structured. The data will not be in a proper organized format. Data is going to enter into the transactional systems, will follow transactions only. Means one customer called to our call center, asked about a credit card. Again, immediately one more customer called about a customer care. Okay, he asked about debit card. Both the transactions are going to maintain the same table only, with the status is different and those things, right? Because of that reason, the transaction storage data whatever we have is not in a proper structure. But while loading this data, these operational systems data into data warehouse systems, we need to make the all related business data, all related subject area data need to make as a one single subject area. That is simply we can call subject oriented. Means what is, for example, if I am creating three subject areas in my data warehouse, one is sales, customers, products. Here sales is a subject area. This sales subject area is going to maintain all sales related transactions only. It never maintain any other kind of data, because of it is going to maintain only limited data, and that limited data also belongs to one single subject area. Due to that reason, we are going to call data warehouse is a subject oriented database. Here is it meaning of subject oriented is nothing but one single table? No, it's a business unit. This, for example, customer is one business unit which is going to have all the customers related transactional data and all the customers related group data, address data, everything we are going to maintain about customers there. That is simply we can call as a customer subject area, right? If you see in this example, we have three subject areas is there. Three subject areas are having three different amount information. Sales have sales amount information. Customers have customers transactional data, and product is going to have the product manufacturing or product related information in a product subject area. Means while loading the data into warehouse, we need to make the data in structure format. What the structure means? Subject oriented format. If any database which we are calling as a data warehouse is not a subject oriented, then we are not going to maintain the data in warehouse. We are not going to call the data in a data warehouse. We are going to call that database as a normal database only, right? That is about the first point regarding to this data warehouse definition, that is subject oriented. Second one is integration of data. When we are working on any data warehousing process, transactional storage systems are going to maintain different transactional systems with the different formats. Assume that we have three systems in there: application A, application B, and application C. three systems are having same column called gender code, right? Here this gender code, okay, if customer is male, we are specifying in application A is M. If customer is female, we are specifying application in same integration of data is application A is F. But same gender code column we are maintaining is 1 0 and application C we are maintaining as X and Y, right? In this case, while loading the data into the warehouse, for example, from application A I am getting 1 lakh records. From application B I am getting 2 lakhs records. From application C I am getting 5 lakhs records. Total 8 lakh records you are loading. Are we going to maintain 1 lakh records or with M comma F, 3 lakhs records with 1 comma 0 and 5 lakhs records with X comma Y? No. Even though different applications of source are having different formats, while loading the data into warehouse tables, we need to make the data in a structured format. That is simply we can call as a, whatever the data we are having is all 1 comma 0 X and Y data also we are going to convert into M comma F. Okay. Here 1X will convert into M, 0Y will be converted into F. Finally, we are going to load into M comma F format in gender code column. Is it mandatory to convert this M comma F only? Why can't we convert into 1 comma 0 or X comma Y? Means that is as per the specification document what we are expecting in target warehouse. If we are expecting a gender code is male value 1, if gender code is female value 0, okay, then we need to convert M comma F and X comma Y will be into 1 comma 0. That is nothing but a encoding format. Means we are going to convert one format to other format. We are going to integrate the data, which is belongs to multiple heterogeneous source of data that we are going to integrate here. That is the first example. There are multiple examples I mentioned in this PPT. If you see here, balance is a column which is coming from application A with a decimal of 13 comma 2, and balance is a column which is having feature class of 99 and V99, and balance is a column which is having floating point with application C, right? Now, while loading the data in target, because three different applications are having same column, right? I'm loading the column name is balance, and these all the data types I am converting into decimal of 13 comma 2. Because my target column balance is having a decimal of 13 comma 2. Then this, okay, mainframe format of picture class data as well as balance, okay, floating point data we are going to convert into decimal. That is going to happen in case of the balance of decimal, okay, 13 comma 2 is the data. And even, okay, different column names also will come, which is belongs to same kind of data, okay, balance on hand, current balance, and third one is balance. The data also we are going to convert into balance field of the this one. And okay, this one also we have one more column, that is data consistency. Data consistency means multiple formats of data will come. While getting the multiple formats of data, we need to convert all the data into one particular format only, right? This kind of integration of data which is belongs to multiple transactions about the multiple stores into single output, this kind of conversions we need to implement on by using ETL tools, right? This is about the integration of data. And third characteristic feature as per data warehouse definition is non-volatile data, because here coming to the volatility of the data, when it comes to the transactional systems, it's going to maintain record by record updation, okay, or one, we are going to insert one record and we are going to delete one record, we are going to change one record, we are going to access one record. Like this, what is going to happen? Whatever the data we have in, okay, Nagaraj, could you please mute yourself? We are getting some noise. Hello, Teja, can you please mute him? Okay, thanks. Here, whatever, okay, data we are capturing in this volatility of the data, here, okay, the data whatever we have, we simply inserting one record, we are updating one record, we are deleting one record, we are inserting one record, we are changing, means A record by record manipulation will happen generally in front end. That is nothing but operation system. But while loading the data into warehouse, we are not going to load one single record. For loading the one single record, we are not going to do any ETL process separately, because the data whatever we have in warehouse will be non-volatile data, and the data whatever we are accessing from this system will be huge amount of data we are going to access and huge amount of data we are going to process here. That is simply we can call as a non-volatile data. Okay, the data which is we are going to maintain in data warehouse is not going to update for every normal change. It's going to update for only major changes. That is simply we can call as non-volatile data. Means data warehouse data is a non-volatile. And last characteristic feature of the data warehouse is, while implementing any database as a data warehouse system, that is going to have multiple dimensional tables. The data which is there in data warehouse will be useful for time variant analysis. The meaning of that one is we can use the data for different type of analysis, like yearly analysis, quarterly analysis, monthly, weekly, daily, product wise, store wise, account type wise, wealth management plan wise. There are multiple ways we can analyze the data, and a data warehouse will generate some historical data analysis tool also. But when it comes to transactional system, because of this, operational systems are going to maintain limited feed of data, and that too, that is not a structured data. That is unstructured data, or that is in a format of transactional data. Even if you want to get any report from this particular transactional storage, even if you broken those systems also, you will not be able to get the data, because that data is not in a structured format. And one more thing is, the data whatever we have in transactional systems are going to maintain normal day-to-day business data only. Because of it is going to maintain day-to-day business data, which is not useful for any calculations. Even though if you broken the data also, we are not going to get any kind of different time variant analysis, right? If any one of the database which is supporting these four features is nothing but a data warehouse. When we are going to call one database is a warehouse, means we are going to call one database is a warehouse if that is supporting these four features whatever we discussed just now. If it is supporting subject oriented, integrated, time variant, and non-volatile. If it is supporting these four features, then we simply going to call as a, that is nothing but data warehouse. Any questions here? Right. If there is no question, then we are good. That is simple definition for data warehouse and operational system in any of the warehouse implementation process. Now, let me show you what kind of basic differences between the operational systems to data warehouse database also. If you observe in operational system how the records are going to be inserted, how the records are going to be changed, and what kind of updations we are going to perform, just let me show you. When it comes to this operational systems, just I'm opening this data. See here, one record is inserted first, the same record got updated, and one record is inserted, updated, deleted, and one record is inserted. Like this, the transactions are going to happen. That is nothing but a operational systems. These operating systems, what is going to happen? For example, in the morning, customer went to bank and he sent a request to bank employees saying that he want to update his address. After half an hour, again he forget to update phone number in the address. He again log into the bank website. He updated his phone number there in bank website itself, right? What is going to happen? First one time is updated, again it's going to update one more time. Like this, this is going to be updated. Sometimes what is going to happen, if account is closed today, then his corresponding transaction will be ended, we are going to set up in a today's date will be end date of the transaction, and simply the transaction information we are going to delete from our transactional storage tables. Means the data whatever we have in OLTP, one record is going to be inserted, one record is going to be updated, one record is going to be deleted like that also. But when it comes to this data warehouse data, it's going to maintain two types of data generally. Just let me show you. When we are loading the data into the warehouse, there are two approaches mainly we are going to follow. One is initial loading of the data. Second one is incremental loading of the data. Okay. What is this initial load? Means the data which we are loading for the first time into the data warehouse database. Simply we can call it initial. And incremental process means what are the data we already have in warehouse. That data we are going to compare with the current data and we are going to process. That is simply we can call as a incremental load also. Means there are two types of load generally we are going to follow while loading the data into warehouse. One is initial load and second one is incremental load. Right? These are the basic difference between OLAP and OLTP, and few more differences I made in a PPT format. Right. If you see first point here, the differences wise from OLTP to OLAP. What is the meaning of OLTP? OLTP means online transaction processing system. OLAP means that is simply we can call as a data warehouse. That's okay. Is nothing but a online transaction processing system is nothing but a front end, and online analytical processing system is nothing but a data warehouse database. Right. First point, if you observe here, users wise, who will access the data warehouse data? Who will access the OLTP data? Here, users wise, OLTP data will access by clerical people, and OLTP data will be used by clerical people. OLAP data will be used by knowledge workers or top level management of that particular company. Very simply we can call as a users wise who will use online transactional systems data, online analytical transaction systems data. And next thing is the functionality wise. The data whatever we have in OLTP, that is used for day-to-day operations. Simply use it to perform daily transactions. Just common example. Today, few people opening an account. Tomorrow morning, to whom we want to send a welcome kits, to whom we want to send a application status, from where we can get from OLTP itself. That's what the data whatever we have in OLTP will directly useful for day-to-day operations. But the data whatever we have in OLTP, that data will be used for making decisions. Okay, that is the first difference between functionality wise. And database wise, if you observe the project what I showed you, account open is on application, credit cards is on application. Okay, some other thing is an application. Like the database design wise, if you observe in OLTP, it's a application oriented database. But when it comes to OLAP, that OLAP is a subject oriented. OLTP is a application oriented, but OLTP is a subject oriented database. And next is data wise. What type of data we are going to have in front end, what type of data we are going to have in warehouse. In front end, we are going to maintain current and up to date detail level data. But when it comes to data warehouse system, it's going to have historical, summarized, multi-dimensional, integrated and consolidated data. If a data which is storing in this one, if these all the historical data, it should be summarized data, it should be multi-dimensional data, it should be integrated data, and it should be consolidated data also. That is a generally data wise. Users wise, OLTP will access the repetitive users, and OLAP whatever we have, while reading or while writing, there will be some ad hoc operation, means huge amount of data will be read and huge amount of data will be extracted or updated in any of the report as well. And few we are going to discuss, not all, not required. And access wise, we have read and write access, and here while fetching the data from OLAP, that simply come from warehouse, we are going to have a lot of scanning operations. Okay, users wise, thousands of users and hundreds of users will access, and database size wise, 100 MB to GBs. Generally, it will be in GBs, it will be in TBs, terabytes. Data warehouse size will be in terabytes. And okay, metric size, if you see, transaction throughput will be there and query throughput. We are going to get the response of the query which is executing to generate any report or something, that is completely dependent upon OLAP. This transaction records, whatever we are doing, okay, every day, that is completely taken care by OLTP. OLTP has transaction throughput and OLAP has query throughput and response waiting, right? These are the basic differences between operational systems to warehouse systems. Any questions on this? Fine. Okay, this is about the data warehouse application information, that is about a operational systems information, and one more thing is OLTP and OLAP differences and data warehouse definition. In tomorrow's session, we are going to start discussing about data warehouse architecture. Okay. Any other questions? Fine. If there is no question, then okay, we are good. Until okay, basics completed, we'll go for a little bit slow because few people are going to join in the middle. Already few people attend a few demos. They will join. Maybe tomorrow or day after tomorrow onwards. Then okay, we'll also combine them, and we'll once the basics is completed, we can okay a little bit speed will go, and okay, we'll also discuss complete practical, not this kind of slides we are going to use while implementing any data warehouse. Yeah, Srini. And regarding timings, okay, all you guys are okay with this timing, or okay, please let me know, okay, what is the compatible timing. I also need to check with another batch people, okay, then only I can confirm. After this batch, I have one more batch is running. I need to talk with them today. Once I talk with them, if they are agree, okay, I want to move them as a okay early or after okay this batch something. What is the compatible time for you?
Sir.
Okay, let me check it.
Hello, sir.
Let me check it.
Hello, sir.
Yeah, Teja.
Sir, అతనికి శ్రీనివాస్ అని ఉన్నాడు కదా సార్.
Right, right.
యా అతనికి వాళ్ళందరినీ మ్యూట్ లో పెట్టినా సార్ నేను. సో శ్రీనివాస్ కి 1 hour అంటే మనం 6:30కి ఇప్పుడు తీసుకున్నాం కదా సార్. అతను ఒక్కడే ఉన్నాడు స్పెసిఫిక్ టైమ్ లో. సో అతను మనీ పే చేస్తాడు. సో యూ ప్లీజ్ పోస్ట్ పోన్ ది క్లాస్ ఫర్ 1 hour. వాళ్ళతో డిస్కస్ చేయండి సార్. మీ వేరే బ్యాచ్ తో డిస్కస్ చేసి అతను ఇప్పుడు మెసేజ్ పెట్టాడు సార్ కింద.
Okay. Yeah, I see that message. That's what I'm telling to Srini.
Okay.
Yeah. That's what. Okay. What I'm telling is okay. I need to check with today next batch. Okay.
Okay.
They are okay. All are okay. I'll okay. Move that to half an hour or 1 hour okay, later. Then we'll try to make it 6 p.m. of. Right now it's 9 p.m. Eastern because in my system also I set up to US time only.
Yes, sir.
I'll try to make it okay 7 or okay.
Okay.
Like, 8 p.m.
7 or 7:30 or 8 p.m. is available. Okay, fine. I'll talk with the students. No problem, sir.
Okay, I'll check it. Okay, I'll check it with them and I'll drop a mail.
Yeah. Thank you very much, sir.
Okay. Any other questions by anyone? Okay. If there is no questions by okay, rest of all the people, then okay, we are good. We'll meet tomorrow and we will discuss. Once okay, all are confirmed, then I'm going to start sending materials, okay, and other software link also you can download, and you can get the installation on into your machines. This is Datastage 8.5 software. You can get into installation and you can start practicing also. Before going to the tool, we will give the software and everything to you. Bye then, okay, we'll meet tomorrow. Thank you. Thank you.
Hello. Hello, John.
Hello.
Yeah, John, can you hear me?